HyperLynx DRC is an automated layout checker comprised of an electrical rule set. Once you've loaded any PCB design, all the information from the layout comes over, including the stack-up, constraints, class definitions, etc. It is designed to automate the boring and tedious manual inspection of a PCB. Typical layout verification is done by eye inspection, searching layer by layer or net by net, and it can become very long and tedious to do. It's easy to miss something as PCBs become complex. HyperLynx DRC provides a better method, a dedicated electrical rule set covering the areas we would inspect manually. To automate this, there's a provided out-of-the-box rule set to get you started and is categorized by signal integrity rules, power integrity, EMI, and safety rules. The tool has its own scripting and debugging environment so that you can write your own custom rules as well. HyperLynx DRC is meant to be a first-pass scan, a way to automate the boring and tedious electrical checks that we have to do. I'll use this first to start my final PCB electrical checking sign-off before manufacturing. Automated rule checking is a very effective and relatively inexpensive way to start simulation and has an easy-to-learn entry point with HyperLynx DRC. If we find some potential issues, we can start using more expensive, deeper dive simulation tools like 3D EM solvers or run DDRX simulations that are contained in the other HyperLynx products toolset. HyperLynx DRC is easy to use and can be ran by anyone, especially the PCB designers, even if they're not simulation experts. The rules themselves have a graphic explaining what it's checking for and why. By having the PCB designers run some of the rules up front for me, it saves them time from manual inspection, and by using them in the layout tool, there's less back and forth between me and them. I can focus my attention on the deeper signal integrity and power integrity problems, the ones that will cause a costly PCB respin. HyperLynx DRC helps us work together. Wilfred showed some of the rules I provided for him earlier, and he used them directly in the Expedition Layout tool. HyperLynx DRC can be used to automatically check any PCB layout, but there is an integration advantage to using it in the Siemens EDA flow, using the layout GUI in the tool PCB designers are already familiar with, and saving them time from learning a new toolset. Because these rules execute so quickly, we can run them virtually every day of the PCB design cycle and catch and correct problems as the PCB designers are adding more components to the board and working on the layout. Some of these rules can be ran at different times during the layout process, during different stages of design, and some of them are intended to run when a PCB is completed. It makes sense to verify high-speed signals such as DDR4 from when they are first placed and routed, and then to check them again when other parts of the board are filled in. This allows us to see if any elements we add contribute to crosstalk or return current path issues, or if any EMI issues seem to crop up or arise. As the board becomes more complex, things change. The power plane might be ineffective if too many vias are added, causing a Swiss cheese effect. Sometimes we have to move placement and decoupling capacitors, can get a little too far away from the IC power pins than we intend. These rules execute very quickly. In a matter of seconds or minutes, they save hours and days of manual inspection. By running them all the time, we are preventing any surprise EMI, SI, or PI issues when we think that the board is complete. By left shifting some of this simulation to earlier in the PCB design cycle like Wilfred demonstrated, we aren't doing one final electrical sign-off at the end of the PCB design cycle. If we only simulated at the end of the PCB design, potentially catching a layout error could be disastrous. Having to go back, move placement, rip up routes, rework the board, and start all over, and then simulate again at the end of that PCB design. By investigating an automated simulation up front and checking and correcting as we go, we save ourselves a lot more time and money down the road. This helps our hardware designers meet their design cycle reduction goals. As the SIPI expert, I have used HyperLynx DRC one last time to make sure nothing was missed by the PCB designers. And once I get all of these rules to pass screen or alert me to potential SI and PI issues, I am ready to move on to some deeper simulation and continue the electrical sign-off.